that there are atomic bombs, but can we be sure that there are atoms? They're too small to see. They exist only in theory. We think all matter is made up of atoms, but can we know that is true? What does it mean to say that anything is true?
In philosophy, there are certain default opinions. There are certain opinions that everybody has to start from and everybody, in the end, goes back to. The default position about truth, the one we all have before we ever start doing philosophy, is the idea that if a statement's true, I say snow's white, or the cat's on the mat, or the sun is 93 million miles away from the Earth, those statements are true because there's something in the world that makes them true. There's something in virtue of which they are true. There's something in the world they correspond to.
Correspondence theory of truth says that a thought, a sentence, an assertion, an idea, if you like, is true just in case it corresponds to some feature of the world. So one thinks of correspondence account of truth as positing a relation between, on the one hand, linguistic objects or perhaps mental objects, sentences or thoughts, something of that kind, and on the other hand, something that's extra-mental, something that's extra-linguistic, so some feature, aspect, thing out there in the world.
The correspondence theory of truth takes the position that there is a reality in the world. We discover that reality and make statements about it. And truth emerges from how well those statements correspond to reality. An approach to science called scientific realism takes a similar position. Science discovers reality. Scientific theories are true when they describe reality accurately.
So realism says, on the one hand, certain things do exist, they have a certain character, and on the other hand, we can come to know that, we can have access to it in terms of our own knowledge and understanding by means of the sciences.
Philosopher Karl Popper expresses a realist view on how science hones in on the true nature of reality.
Although I do not think that we can ever describe by our universal laws an ultimate essence of the world, I do not doubt that we may seek to probe deeper and deeper into the structure of our world, or, as we might say, into properties of the world that are more and more essential, or are of greater and greater depth. Every time we proceed to explain some conjectural law or theory by a new conjectural theory of a higher degree of universality, we are discovering more about the world, trying to penetrate deeper into its secrets.
One challenge that has been posed to correspondence theory and scientific realism is that they are limited. They don't cover all the situations in which people commonly refer to truth.
What makes a logical statement or a mathematical statement true isn't in any very obvious way that it corresponds to something out there in the world that might not have been out there. So you need a special account of truth in logic and mathematics.
Anything that's within the scope of rational thinking, and in particular of logic, is subject to being called true or false. I don't think that everything that is subject to being true or false in that sense is a description. And I think as long as we think that everything that's true or false has to be a description of some realm, we won't understand ethical truth, we won't understand logical truth, we won't understand mathematical truth.
A theory of truth that many people find more applicable in these kinds of situations is called the coherence theory. It maintains that an idea is true when it coheres with or fits in with other ideas. Brand Blanchard gives an example.
It is perhaps in such systems as Euclidean geometry that we get the most perfect examples of coherence that have been constructed. If any proposition were lacking, it could be supplied from the rest. If any were altered, the repercussions would be felt through the length and breadth of the system.
The coherence theory was part of idealism. Idealism, you remember, says there is no real world. There's just our system of representations. Well then, what's truth? If there's no real world, well, truth just consists in how our various beliefs and thoughts and judgments cohere with each other.
Coherence theories don't necessarily contend that truth depends entirely on coherence among ideas. They can, for instance, say, look at scientists. How much of what they do depends on describing reality, and how much depends on getting their ideas to cohere?
When a scientist goes through a process of empirical confirmation of a theory and praises it as the best candidate among the available theories, he doesn't compare the theory with reality, except in this highly indirect way of making it square with the beliefs which reality has forced him to acquire. And if a philosopher comes along and says, given that the relation between your theory and reality is this incredibly complex, indirect thing, why do you think your theory is true of reality? The scientist should tell the philosopher, look, this is what we mean by a theory being true of reality. It's just a theory which renders as many beliefs coherent as possible. What more do you want?
The idea that scientific theories are considered true because they cohere with other theories was voiced most forcefully by Thomas Kuhn in his 1962 book, The Structure of Scientific Revolutions.
2 days worth of earthquakes, September 9th.
In Kuhn's view, every scientist works within a conceptual framework called a paradigm. A community of scientists agree about that paradigm and use it as a foundation for their work. A new theory is true for them only if it fits into this paradigm.
I like to call these things consensus theories of truth. They come in different varieties and flavors, but the basic idea is always the same, namely that an assertion, a sentence, an idea, a thought, a theory, if you like, is true, just in case the right people believe it or would believe it under the right circumstances. And that's, of course, entirely a human-centered concept of truth.
The belief that truth is human-centered contradicts the realist belief that science can capture the reality of nature in theories. Thomas Kuhn describes the conflict.
We're all deeply accustomed to seeing science as the one enterprise that draws constantly nearer to some goal set by nature in advance. But need there be any such goal? Can we not account for both science's existence and its success in terms of evolution from the community's state of knowledge at any given time? Does it really help to imagine that there is some one full, objective, true account of nature, and that the proper measure of scientific achievement is the extent to which it brings us closer to that ultimate goal?
Yeah, I think the whole idea of one truth is a bad leftover of Greek metaphysics and Christian theology. I mean, I think the notion of one truth is basically just the notion of one God, the powerful father figure of monotheism, the figure to whom we owe absolute obedience, who has authority over us. And this is just an idea that we would be better off without.
To compare Popper's and Kuhn's positions, consider how they look at the shift from Isaac Newton's theory of gravity to Albert Einstein's. In Newton's theory, gravity is caused by attraction between bodies. The planets stay in orbit around the sun due to the balance between the pull of gravity and their own momentum. In Einstein's theory, large masses curve the space around them. Planets move through the curvature of space around the sun. Attraction is not a factor. How should we look at these two theories? Popper contends that gravity is a fundamental feature of reality. Newton's theory probed it deeply, but Einstein's theory probed it even more deeply and gave us a truer account of the universe. Kuhn, by contrast, questions whether we can think in terms of fundamental reality. For him, both theories are simply paradigms, explanations that were widely accepted by scientists in different eras. Indeed, Kuhn takes exception to the whole realist effort to base the search for truth on a belief in objective reality.
There is, I think, no theory-independent way to reconstruct phrases like really there. The notion of a match between the ontology of a theory and its real counterpart in nature now seems to me elusive in principle.
Kuhn's view that all theories or paradigms depend on consensus within a community and that paradigms come and go has often been criticized as relativism. In relativism, all theories are tied to a point of view, and there are no independent standards for truth. Kuhn vehemently denied being a relativist and defended conventional standards for evaluating scientific theories.
He always insisted that, first of all, he accepted the standard moral values. I call them moral deliberately, where you prefer theories which are simple, which are not ad hoc, don't just try to fit things in, which honor the largest amount of data which is available, which provide more predictions and explanations than were available before. Standard things out of a science textbook of 200 years, of science methodology textbook of 200 years ago, said, I have all those values. They just don't determine what happens in the course of actual scientific research. And he said that to be a relativist would be to dismiss all our usual markers of truth and success in science.
This side has a lot of clay at it, Don.
Both correspondence and coherence theories of truth have been criticized for their abstractness and dependence on arguments. Often the truth seems to depend more on what works in the real world.
The way in which we can judge our beliefs is by testing them in experience, by seeing if they can sustain an industry, whether they can predict the outcomes of experiments, whether they can provide tools that will keep an economy going.
A theory about truth called pragmatism arose in late 19th century America. In his 1907 book, Pragmatism, A New Name for Some Old Ways of Thinking, William James contrasts pragmatists with what he calls intellectualists.
Truth, as any dictionary will tell you, is a property of certain of our ideas. It means their agreement, as falsity means their disagreement with reality. Pragmatists and intellectualists both accept this definition as a matter of course. They begin to quarrel only after the question is raised as to what may precisely be meant by the term agreement and what by the term reality. The great assumption of the intellectualists is that truth means essentially an inert, static relation. When you've got your true idea of anything, there's an end of the matter. Pragmatism, on the other hand, asks its usual question. Grant an idea or belief to be true, it says, what concrete difference will its being true make in anyone's actual life? What is the truth's cash value in experiential terms? The moment pragmatism asks this question, it sees the answer. True ideas are those that we can assimilate, validate, corroborate, and verify. False ideas are those that we cannot. The truth of an idea is not a stagnant property inherent in it. Truth happens to an idea. It becomes true, is made true by events.
Pragmatism was influenced by Charles Darwin's ideas about the survival of the fittest. In contrast to theories of truth based on abstract ideas, pragmatism can be seen as grounded in basic biology.
Early creatures in evolutionary history had the problem also of representing the way the world is. But they weren't interested in mirroring the abstract structure of the world. They were interested in lasting through breakfast till lunch and getting their genes into the next generation. And so pragmatic criteria tended to steer both the nature of their biological organization and the beliefs and concepts that they embraced in the course of a lifetime. I think we're still in the same position.
And I think this is where pragmatism eventually takes you. My own view is that theorizing is itself another form of practice, and that what makes theorizing intelligible is that we can understand it as a practice. You know, in the course of some practical activity, whether it's clinical medicine or physical astronomy or whatever it is, we appeal to theory. But what makes this appeal to theory okay is what it does for us in relation to our practice.
In science, pragmatism is sometimes called instrumentalism, since it sees theories as instruments or tools. The truthfulness of a theory depends on how well it generates predictions that produce results.
Now, instrumentalism holds, very roughly, that what we aim for in our scientific theories is not the truth about an external world, which is the realist position, but what we aim for in our scientific theories is something like utility, which would be the instrumentalist word. I like the word reliability better. So what we're aiming for are theories or accounts or pictures or models of the world that are reliable. Reliable for what? Well, for whatever purposes we might want to put them to use.
Sometimes a theory may show its pragmatic value by producing results outside of science. Other times it may do so by improving practice within science.
You introduce a concept, new term into science, new definition, new principles coming with it. On what basis do you do so? Well, you find that if true, if experiments bear it out, it's going to simplify the theory. It's going to draw two separate parts of the theory closer together. It's going to make it possible to do some more experiments of a decisive kind. It's instrumental for that.
So our theory should be reliable for crudely instrumental purposes, for building bridges and airplanes and making exquisite video equipment. But our theory should also be reliable as reflective tools for exploring some aspects of the world around us that we haven't yet come to terms with and perhaps even yet begun to conceptualize.
Perhaps the sharpest debate between realist and instrumentalist views of science has come in relation to quantum mechanics. This modern offshoot of physics concerns atomic and subatomic particles and has triggered breakthroughs in fields such as atomic energy, lasers, and electricity. Since atoms are too small to observe, theories about them are by necessity highly speculative. Experiments in the early 20th century suggested that it is not even possible to say if electrons are particles or waves.
When you run beyond the limits of even extended observability, you run precisely the case where you really have great difficulty in knowing what to say about questions like real or not.
One group of physicists, headed by Niels Bohr, adopted what became known as the Copenhagen interpretation.
The dominant view of people who came to practice in the quantum theory was an instrumentalist view. That is to say, they thought the theory did not give you a picture of the world, but it gave a calculational tool.
We accept it not because we understand it, because we don't, but because it leads to predictions to more decimal places than we ever imagined a scientific theory could lead to true predictions, and continues to surprise us with how immensely accurate it is, even though, as I say, we understand it only in the sense of knowing how to manipulate it mathematically.
In the famous double-slit experiment, for example, You shoot electrons through two slits onto a collecting screen. If electrons behaved like larger objects, such as bullets, you would expect them to strike the screen in the pattern of the slits. But they don't.
And the quantum theory gives you a very accurate, uncannily accurate prediction for the pattern that you're going to get on the collecting screen. It's going to be a characteristically wavy pattern.
Even more startling, quantum theory contends that there is no way to determine the path any given electron takes to reach the screen.
So what you can say on the basis of the quantum theory is the particle leaves the source and it arrives on the detecting screen, but you cannot say how it gets between the source and the detecting screen. You cannot even say, and this is what's quite remarkable, that it goes through one slit or the other.
Previously, scientists had assumed that Newton's mechanics correctly described the motions and interactions of all bodies. But now Bohr and others argued that Newton's laws did not apply at the quantum level.
The kind of question that you can ask on the basis of classical physics of a moving body is you can say, where is it at a given time? How fast is it moving? And in what direction is it moving? So you can ascribe to a moving body both a position and a velocity, velocity being speed and direction of motion. According to the quantum theory, as it was generally understood, one could not do the same thing for a moving quantum object, for an atom or a molecule or a subatomic particle of some kind.
In quantum theory, you can measure the position or velocity of a particle, but not both at the same time. And so Bohr argued that we should give up trying to say what might really exist at the quantum level and simply use quantum theory as a calculating tool.
I think Bohr's counsel was partly a counsel of despair, that he thought that we are never going to understand quantum mechanics, or that it's intrinsically beyond the power of the human mind to understand it in the categories that are the only categories he thought we have available to us, space, time, and causality.
The realist side of the debate was championed by Albert Einstein, the father of relativity theory and the most eminent scientist of the era.
Einstein had a sense that if you began to take a very pragmatic attitude towards physics, Einstein had the sense that physics would degenerate. For Einstein, physics was a kind of grand intellectual adventure. For Einstein, physics was discovering the finer aspects, the deeper structure of reality. Sometimes Einstein would put it in religious or quasi-religious terms. It's as though he thought that God created the universe in a way that made it difficult for human beings to comprehend, but not impossible. He had this wonderful phrase, the Lord is subtle, but not malicious. And what he meant was exactly that the Lord makes the features of the universe difficult for us to find, but he wouldn't lead us to seek those features unless we could find them.
Although the arguments are very complex, the alternative Einstein proposed was that if quantum theory broke down categories such as space and time, we should think of new and deeper categories.
If it's really true that position and momentum fragment in this way, so that you can have one or the other but never both at the same time, then in Einstein's eyes, this provided grounds for saying, let's look for a different set of concepts, right? Let's try to understand the world conceptually on the basis of something new.
Most importantly for Einstein, whatever new concepts we developed, they should attempt to describe the underlying structure of the universe.
And so Einstein maintained this faith that that's really, in the end, what physics was about. Physics wasn't about tinkering. Physics wasn't about experimental prediction. Physics was finding out the most exquisite, deeply hidden features of the universe. And this is a typical kind of realist orientation. One of the things that always separates the realist from anti-realists of various kinds, and certainly from the pragmatist or the instrumentalist, is the realist always wants to probe deeper and deeper and deeper to find out the more hidden and the more exquisite features. The instrumentalist wants to understand what needs to be understood for certain kinds of tasks, but then is content to say, let's leave it at that unless circumstances force us to push forward.
Einstein spent the last 20 years of his life in an unsuccessful attempt to develop a unified field theory that would provide a realist explanation for quantum phenomena. For many years, Bohr was seen as having won the debate. But in recent years, the balance has shifted somewhat back.
I think there's a growing perception that although Einstein wasn't right about everything about quantum mechanics, in the debate with Bohr, he was at least onto the existence of a real puzzle and a real problem. And now, in fact, a lot of interesting work in quantum mechanics over the last 5 or 10 years has been the development of new alternative interpretations, detailed interpretations of quantum mechanics.
What is truth? In both philosophy and science, various theories have attempted to provide an answer. Each seems to contribute a vital perspective. But do any cover the whole picture?
I rather admire the things that Richard Rorty has said about the importance in philosophy of not getting hung up on big words with capital letters, big words with uppercase letters, truth with a capital T, reality with a capital R, proof with a capital P, and so on. But realize that in ordinary life, what we're concerned with is truths in the plural with a small t.
Or the attempt to find one characterization of truth that covers every kind of truth seems to me now doomed to failure. It's like the attempt to find one account of the scientific method which covers every single kind of scientific situation, every single kind of scientific hypothesis. It's a tendency in philosophy to look for the generalization that covers all the cases, and we always lose, but we can't resist trying.
The Examined Life is a 26-part series for college credit. To purchase a video cassette or transcript of this program, call 626-796-7300 or visit us online. Please order by program number.